Chapter 4 is polynomials. We're continuing with the polynomial theme. Okay, chapter 4 is polynomial equations and inequalities. So we're going to add inequalities to it. We weren't doing equations before. What we were doing was we were factoring part of it. We were factoring it whether it had y equals or not. We were doing this part of it just the right side, and we would be factoring it. Sometimes we wouldn't have a y equals, and we would just factor whatever expression we gave you. So now we're definitely putting it towards an equation. So equations. So it's equations this chapter and inequalities. Still polynomial. Okay, still in the theme of polynomial, which continues from chapter 4. We're going to use all of our factoring skills. So everything we know from before, all of our factoring skills since forever, since grade 10, in order to factor and solve. Okay, so we're going to factor and solve all of them. Okay, you can check by substituting. If you want to check your answer, so if I say x equals 2, if I substitute it back in, I should get that equals 0, right? So you should get the same answer. So I'm saying you can check it. What I'm going to highlight here is that you should always check it in the original equation. As soon as you do any manipulation with the equation, like if I bring the 27x to the left side, if I forget to make it negative, I've already made a mistake. Then if you check your answer, which is wrong in your wrong equation because you made 2 mistakes, sometimes in math 2 mistakes will make it right, but you're still wrong. Is that weird? But yes. So you're wrong, you're right, but you're still wrong because you were double wrong, which makes it a right, but you're still wrong. Ha! So don't. So check it in the original. So the main point here is that check it in the original, not in whatever you did to the equation. So as soon as you bring the 27 over, as soon as you brought that over, you might have made a mistake, right? So check it in your original, that left side equals right side. So back to the grade 9 kind of check idea. So original. You should check all your solutions. If you get like 3 or 4 solutions, you should check all of them. And we'll talk about that later on. So we'll talk about checking later. Okay, so for now, we are going to state the zeros, which are also called the roots, which is also the same thing as an x-intercept as well, right? So we've done that since forever. So we have, okay, x-intercepts, which is root, which is 0. So all of these words mean the same thing, right? All those words mean the same thing. So just like from last chapter. So last chapter we would do this and state the zeros and then graph it. So we're going to state the zeros. I don't say graph it, so you don't have to graph it. We're just going to state the zeros. So we're going to state the zeros here. We're going to get 3x. Oh, sorry, I was distracted by the printer. So we're going to get x equals, so for this 3x, we're going to get x equals 0, like that, okay? For the next one, this one, we're going to get x equals 2, right? X equals 2. Okay, and then for the next one here, we're going to take this guy here and try to solve it. Now, we could have solved this as already last chapter as well. We wanted to see if there was any x-intercept. So for this one here, we're going to take this one and we're going to use x equals and negative b plus or minus b squared minus 4ac all over 2a. Okay? That is the quadratic formula that we know from before. Okay, that we know that from before. And that will equal, and we're going to sub in. Okay, we're going to sub that in. So we're going to get 6 plus or minus negative 6 squared, 4 times 1 times 10. You don't have to show me the times 1, and it's 2 times 1. You don't have to show me that, right? You can go straight to, right? So you can skip some of the little mini steps here. You can go 6 plus or minus. When I get this, I'm going to get square root of negative 4 over 2. Okay? When you get that answer, you see this negative here. That negative is going to tell you I cannot go any further, right? I cannot take the square root of a negative. So then this is going to give me no solution. You can say no solution like that. Okay. At At the end of this, I always want you to summarize what it is you found, because you have bits and pieces around. So you're going to say, therefore, x equals 0 or 2. 0 or 2, and then I got no solutions from the other ones. Okay? All done. So I always want a nice little concluding bit here. You don't have to underline it, but I want a concluding bit so that you kind of summarize. So especially when we get to powers of 4 and 5, there might be more than, right? There's more than 2 answers. It could be 4 answers, could be 3, whatever. Okay, so next one. So that's just like what we did before, right? We're solving at the roots. Here, I'm going to point something out. So we're going to take this guy, and we're going to solve it. Remember, we're solving a polynomial. Right? A polynomial, we know the definition of polynomial, right? Polynomial means that there's x's, there's coefficients, can be any real number. The exponents can be any integral, or no, sorry, not any integer number, any whole number. So 3, 1, no negatives, no roots, no nothing like that, right? So for this one here, we are going to take this over to the left side, and I'm going to explain some stuff after that, but let's do this first. So we're going to do it like this. We're going to bring that over to one side. So we're going to go 3x cubed minus 27x equals 0. Okay, we are going to take a 3x out, and then we're going to go x squared minus 9. That can be factored further, but the question says what? You usually don't even read the question. Did you read the question, or did you start doing it? Yes, we don't. We don't read. We don't read because we're so excited to do the question. Did you stop and read it? It says solve. It doesn't say I have to factor fully. So you can take this and solve it. Or you can factor it again. It's up to you. So for solve questions, so please read it. If I said factor fully and solve, you would have to factor fully, and I'd need it factored fully. If I don't say that, you can go from here, right? So if I want to factor fully, I would do this, right? So that is factoring more. Factor fully. So if the instruction said factor fully and solve, I would need to see that. It does not say that. It does not say that. I don't need to do that. I can go from here and solve, right? See how it's slightly different? You're going to get the same answers, though. So from here, we're going to get this one, x equals 0. We should be able to do that pretty fast now. And for this one, we're going to get x squared minus 9 equals 0. You can go a little faster. X squared equals 9. And then x equals positive or negative 3. Yes? Okay. Would have I gotten the same answer if I factored fully? Yes. You'll get the same answer if I factor fully or if I go ahead and solve right away. But because the question says solve, it's up to you. You don't have to factor fully. You can go from here or factor fully and solve. One second. I want you to do a therefore statement. So again, so I don't have to go back and find your answers. I don't want you to do this. I do want you to do this. Okay? So I want to therefore, so I know the answers are all there. I want you to make sure you gather all my answers for me, please, one more time. Okay. I want to point something out. Okay, I'm going to point something out. What happens if you took this question and you absolutely and totally lost your mind and did this? Watch. So 3x cubed equals 27x. So you lost your mind. It was a zombie apocalypse. You were being chased by people. They were going to hurt you. You went, oh my gosh, do you know what I'd like to do? I'm going to divide both sides by 27x and do this. Then I would forgive you. But because there's no zombie apocalypse, you cannot be forgiven for doing this. This is not allowed. Cross off, you go, oh, 1, 9, you get 1, 9, x squared. And you go, no, I'm going to get the same answer. Are you, though? So the 9 comes back up, and you get x equals positive negative 3. Is that the same answer as my answer? No. You're missing this because you lost your mind and created a rational expression. Rational means fraction, right? You put an x in the bottom to create a rational by putting an x. Can I divide both sides by 27? Yes. That's not creating a rational. Dividing by an x creates a rational expression. Canceling this out means you created a whole. Bump, bump, remember? When you cross off top and bottom, it's a hole. You poked a hole in my answer and you popped out 0. You went, meh, gone, no 0. You created a rational expression, so this makes me, those are my eyes, and I'm sad, cry. If you want to make me cry, do that. Okay? You're creating a rational. You're doing two things wrong. You created a rational, and then you poked out a hole, and you dumped out my 0. You do not create a rational. You create the rational. What am I saying? Don't divide by an x. You know the difference between a polynomial, right? So now we know. Polynomial's this is a rational. You're creating a rational from my polynomial. You're dumping an answer. How did you dump it? You created a hole and you poked it out. And you don't even have it anymore. It's gone. Do not divide by x, ever. Don't divide by x plus 1. Don't divide by x's. Whenever you divide by an x, you're creating a rational, right? We get that now, rational expressions, right? We know top and bottom with x's. It's a rational expression. You're canceling it out, which we know means a whole. So you've dumped out a whole and you've dumped an answer. This is not allowed, so do not, so I'm going to put that down, do not divide, so do not divide by x. Any x. We are not putting x's in the denominator because you create a rational, does that make sense? A rational expression, which we did way back in grade 11, right? So you would create a rational expression where we did our restrictions, and we found that our restrictions were wholes and asymptotes. You're creating, and by canceling away, you dumped out an answer. That's why, because sometimes you're like, why does it matter? Because you're actually canceling away an answer. You're canceling the whole. Okay? So never divide by x, ever, ever, ever. Okay? I will put the crying face on your test. I will have there and tears coming out. And you'll be like, uh-oh, I canceled an x. Do not, you're creating polynomial. You know polynomial. You're creating a rational from a polynomial, and it's wrong. Can you divide both sides by 4? Yeah, I can divide both sides by 4. Go for it. Happy day, happy day. Divide by 4. That's not creating a rational. Dividing by a number is okay. I get x to the 4 equals 3x squared. That's fine. You can divide by a number. So I'm going to put that down. Divide by a number is okay. That's happy. I'm okay with that. Right? Divide both sides by a number, it's okay. Dividing by an x means you're dumping out an answer. You're creating a rational expression where one wasn't. Okay, does that make sense? Everyone always argues that. They're like, wait, why can't I? So am I going to divide both sides by x squared? Never. Can I divide both sides by 4? Absolutely, go for it. Okay? Can I divide both sides by x squared? No, because it creates a rational and you're dropping an answer. Does that make sense? Why? Okay, polynomial, not a rational. You're creating a rational where one wasn't. Okay, so don't do that. So instead, we're going to bring it to one side and solve. So x to the 4 minus 3x squared equals 0. Okay? Factor, don't cancel an x. Never cancel x's. You're creating a rational expression. So x squared minus 3 equals 0. And let us solve. Okay, so from here, we're going to solve. So this one and this one, we're both solve. And we're going to get x equals, here, x equals 0. Sorry. X equals 0. Okay, and then here, x squared minus 3 equals 0. Are we okay with that? Yes. Yes. Absolutely. So definitely, I was going to show you that here. So if we did it the other way as well, we could have done 4x to the 4 minus 12x squared equals 0, and yes, we would just factor out the 4. So instead of dividing out the 4, you could have factored it out, and you would get the same thing. So x squared minus 3, beautiful. So or. That is totally fine. So you do a common factor 4x squared instead of the x squared, and look what happens. We're at the same spot. We're still going to get x equals 0 in this one. So we'll get the same. So this is beautiful. So either way is fine. Divide. That's why dividing by 4 didn't get rid of an answer. Dividing by an x squared would have gotten rid of an answer, because you're creating a rational, right? A rational expression where 1 wasn't, and then popping out holes. Okay. So here, now, when you solve this, okay, when we solve this, sometimes what happens with these guys here is you autocorrect what you think the answer should be. So just make sure in your brain you slow it down a titch. So you're going to go x squared equals 3. I get people who go x equals positive negative 3 because you're thinking square root of 9. It's not. It's positive or negative root 3. Okay, so just be careful you don't auto-correct yourself. Sometimes you're like, oh, you must mean for it to be a whole number. No, I like irrational numbers too. Root 3 is beautiful. It's good. We had that in chapter 3 too. It's not a bad number. Okay, people just auto-correct and go, oh, you must mean for it. No, no, that's a beautiful number. So then we're going to go, therefore, x equals 0 and positive negative 3. All done. Okay, so you get that one, put it all together. Okay, so don't auto-correct my answer. Plus, also, the thing I'm going to point out here is okay, squared means positive negative, right? We talked about that before. We don't want to forget that. Yes? Oh, see, exactly that. Ha! I was auto-correcting. See? And that's why you should never have your phone beeping on the side. You heard it beep? I was looking there because I was waiting for something. Never. So that's why everyone's phone should be off their desk, not on their desk. And when you're in lectures next year, off your desk, right? Because it's the whole anticipating. I was waiting for a response, and so I'm thinking of that. Bad, right? Studies have shown, not on your desk at all, not even there. It's even having it, even silent, upside down, it's still in your visual. So when you're in lectures, I want it away. So picture me, hear me nagging you in university, post-secondary, okay? Like, oh, Ms. Zen said to put it away. Put it away, okay? Unless you're recording. Apparently some people record if they're allowed to, they record their lectures because they want to hear it again later, but it's hard to hear from the lecture and stuff like that. So not everyone records their lessons. Okay, all right, so off your desk. Bad. See, off, and it should be off. Okay, so here, try that again. Does that make sense? So again, watch out for that positive, negative, and yes, watch out for the square root, which I, again, did it myself. Perfect. And then yes, either way is okay. Dividing by numbers, okay. Dividing by x's, never. You're creating a rational where 1 wasn't, and you're poking out holes when you cancel. Okay, holes in your answer. Okay, try it again. So here we have x cubed. We know how to factor this. We know how to factor this in every way that we've done before. So all the way back from grade 10, right? 2 by 2, 3 by 1, we learned in grade 11, and now in grade 12 we learned how to do synthetic polynomial. So don't throw away your previous factoring. I'm going to do the 2 by 2. It will also work if you use our synthetic, okay? But I wanted to remind you one more time of the 2 by 2, which we learned way back in grade 10. How do I know when to use that? I know because I looked at the ratio of the numbers. It was 4, it's polynomial, so it's 3, 2, 1, nothing, right? So it's 4 to negative 12 when I look at the coefficients, and then negative 1 to 3. Those are actually in the same ratio, right? It's a 1 to 3 ratio, negative 1 to 3. So because of that, I can do a 2 by 2. If I can't, I would do synthetic, right? Look for the factor theorem, etc. So I wanted to practice the 2 by 2 just one more time, right? Because again, it's been a while. So 4x squared, and I get x minus 3. If I take out negative, I get x minus 3 equals 0. Okay, so then we're going to take the x minus 3, and we get 4x squared minus 1. Okay, so I wanted to remind you of that from grade 10. Also, wanted to practice this one more time. Again, we're not going to auto-correct stuff, so we're going to be careful. This one here, I know for sure. This one is just x equals 3. All done, easy peasy, right? This one, just be careful. We're going to take this one, and 4x squared minus 1 equals 0. You can skip that step and go 4x squared equals 1. X squared equals, and again, don't autocorrect and make it 4. It's 1 over 4. Okay, you guys tend to make these little mistakes where you go, oh, it's a whole number, and you just do silly things. Divide it by 4, so it's 1 over 4. So x equals positive or negative 1 over 2. Okay, again, I see a lot of people, they just flip the 4 over, right? And you're doing little linear mistakes, but we know, divide both sides by 4, so 1 over 4, so it's 1/2, positive and negative 1/2. Okay, so don't do an autocorrect thing, just slow it down enough so that you're not making little mistakes. Yes?
I don't really remember this, but why did you change the sign on the x plus 3 at the very top?
Oh, here, we're going to take out the negative from both of them. So because I factored out this negative, then I factored out negative from both of those guys. And it made it -3, and it makes it match. Yeah, right? So then, and if those two don't match, then I can't take out the common, right? So we want them to be matching. So if I take out a negative, that makes it a positive x and a -3, which matches the other one.
Yeah, it's just confusing because the negative is already there.
Yeah, so the negative, exactly. So it started with a negative, and you can picture a 1 if you want, right? So picture the 1 if you want, so -1 comes out from both, right? And we want those two brackets to be the same. Okay, then, all right, next one, we are going to do the next one. It's already factored for you. I'm just gonna draw a line here so that you can see where my answer was. That was for this question here, and then this is for this one here. Okay, so then this one here, it's already, oh, sorry, and also we're gonna keep it steady with the rule that I want fractions, not decimals. I know that you could do 0.5, but we're gonna leave everything in fraction form unless I ask for decimals. So fractions, okay, fractions, yay, not decimals. Okay, unless I ask for it. I know it's an exact decimal, 0.5. Let's leave everything in fraction form. Okay, so fractions, not decimals, unless I ask otherwise. All right, this next one, it is in factored form. It already equals 0, so I don't have to bring anything over. I just have to take each bracket and equal 0. Again, just don't do the autocorrect. I'll show you where a little mistake happens sometimes. 5 gets no answer, so we're okay, no variable. Here, we know from this one, x equals 4. We're good for that one. This guy, sometimes you autocorrect it again, right? And you go x equals, right? And you autocorrect it to 9. Okay, it is -9, so can you solve that? You can't, right? So x squared plus 9, it's not a difference of squares. I didn't make a typo, right? So it's actually that. So when you bring this and you try to square root it, and you go x equals positive negative root -9, as soon as you see this, as soon as you see it, you can stop right away. You can go from the beginning and go, you know what, I saw it from here, no solution. Right? You can, as soon as you see it, you can jump to no solution. If it takes you a step before you see it, that's okay. But don't autocorrect it and go x squared equals 9. Right? Because you go, oh, I'm fixing her question. Don't fix, my question was written right, so it's plus 9, which means it -9, which means no solution for that factor. Okay, not every single one will have a factor. Okay, let's try it again. Then this one, we're going to bring over here. Okay, ready? Take this one over here, and I'm going to slow it down again. Plus equals 0, like that. Okay, x cubed equals -8. Okay, and then x equals, and it's the opposite to get rid of the third root. Oh, sorry, I just said it. To get rid of a power of 3, it's third root. Right, so third root of -8. You can skip that part, right? You don't have to show me that. You can go here to x equals -2. It's only -2, not positive negative. We only do the positive negative for squared, but for third roots, it's only going to get one answer, right? So don't do an auto thing. Yeah. X equals 4. Would I write what? Sorry?
That's an order 2.
Nope.